Good. So I had a little bit of a problem when I showed up here, was that I realized that all the things that are most recent, that I'm most passionate about, are going to be presented by my students and collaborators. So I don't get to talk about any of the really super recent stuff, but you get to hear it all, and I'll give you pointers at the end. But I'll still try to be entertaining and informative, and hopefully we'll say some things that will help you in your career and day-to-day life here. So the thing I want to talk about is, how do human social networks determine decisions and performance? So that's a complicated question, obviously, because at least traditionally it has to do with information and arguments and logic and so forth. But we also know that there are just simply effects of exposure, of information foraging, fairly simple processes that you can see in animals that also are present in people. And that's the stuff I'm going to mostly look at. And then the question of how can we shape these networks to derive better performance and better decisions. So those are the things that I'm going to look at. And in the context of the previous speakers, what I'm doing is I'm doing just what they try to do, but with humans rather than fish. So I'm going to divide this into two pieces that are based on the two ways that we tend to measure people. So one way is we have these little badges that we build that include location, they include face-to-face communication, who's facing who. They know when you're talking. They don't record any words at all. There's this handsome guy over there, Manuel, who is in the picture. And what that lets us do is measure all the communicative acts, all the interactions that we get within an organization over a period of a month. And we typically take an entire chunk of an organization, like a department in a university, or the drug discovery part of a pharmaceutical, and we do that. And these are now made commercially by a spin-off of ours, Sociometric Solutions, and they're available on a not-for-profit basis for research, if you're interested. So let me just show you an example of the sorts of things that are surprising that you can get from this. So 2 years ago, we published a paper in Science about group intelligence, looking at hundreds of groups performing many different tasks that were carefully instrumented tasks. We knew precisely how well the group was doing, and then asking what were the characteristics. And some of the surprising things were the intelligence of the group, the objective performance of the group, was not correlated with the average intelligence of the members of the group. In fact, the things in that paper that were highlighted were social intelligence, ability to actually relate to what other people were doing, and equality of contribution. And that was measured using these little sociometric badges. After the publication, though, Wen Dong, who's back here somewhere, and I went through this data and found something that is, to me, even more surprising, which is if you just took no content at all, you don't know who the people are, you don't know what the task is, if you took the total number of contributions, these are not linguistic things, these are silence, verbiage, silence, that's a contribution, and the amount of back channel. So people going, uh-huh, yeah, really? Tell me more. Little short comments back. And then the equality of contribution, you could make a linear predictor that accounted for 50% of the variance in the performance of these hundreds of groups. That means that the pattern of communication accounts for more variance than everything else put together. So all that stuff you learned in school about debating strategies and all that other stuff, forget it. You can beat it by just looking at the pattern of communication. Of course, the stuff you learn in school, the strategies, the social intelligence and so forth, are what determines the pattern of communication. So it's not completely anti-intuitive. But it's interesting that these sorts of patterns are so strong. Now, we take these and we go out into the world and we instrument entire organizations for a period of a month. And through doing this on a couple of dozen organizations now, we've found some patterns which shouldn't really surprise you. We do them slightly different than other people, but they relate to the amount of communication, call that energy, something that has to do with network constraint, which you're familiar with and is related to Q, which Brian Uzi has looked at, which we call engagement. It's slightly different than those things. And something that we call exploration, which is like path length, which is like information harvesting. And they have very simple mathematical formulations, but they have nothing to do with the content. So we're just looking at the pattern of communications, face-to-face communications within an organization. And this is the typical result that we get. So this is a bunch of people who have master's degrees that live in this city. They work in a back office operation. Salesmen call in requirements for computer systems. They configure those things and send them out. It's not a trivial task, but it's not rocket science either. We know precisely how many dollars they make because we know what the thing sells for and how long it took them to do it. And if you ask about productivity, and these are hard dollars per minute, okay, what you find is that about 30% of the beginning group between individual variability is accounted for by this engagement measure, which is like network constraint. In other words, do the people that they talk to also talk to each other? And about 10% of it is accounted for by what we refer to as exploration, which is do they get outside of their immediate group, and how much do they do that? So that's hard dollar productivity as a function of these sorts of things. As I mentioned, we've done this on some 24 organizations, including some Fortune 100 companies. A typical result is this sort of result where we get around 40% of the variation between low-performing individuals and high-performing individuals, or low-performing groups and high-performing groups, as a function of these two simple properties of the network, independent of the content. Now, this is face-to-face stuff. When you add email like here, so the blue here is email, the red is the network of face-to-face. So this is the evolving pattern of communication in a creative department of a German bank over a period of a month. What you find is that there are complicated interactions between the different communication networks. But by looking across the networks, you can get similar sorts of results. But if you're looking at only one network, like just email, you don't see the whole picture. If you're looking at just face-to-face in a richly email-connected group like this, you don't see the same picture. Sort of obvious, right? But we forget it. We tend to analyze these unidimensional networks. So I said I wanted to talk about shaping social networks. So the simplest thing to do is you just give the humans feedback about what their pattern of communication is. So this is a nice illustration that the Times did of some of our work. So these are teams that were in Japan. Some of them are Japanese. Some of the teams are American. So this is what a typical pattern of communication would look like on day one. The Japanese were very quiet. They're the ones down at the bottom because their cultures are rather different, right? But if you gave them a diagram at the end that showed the amount of interaction they have and the amount of participation that they had, so how much they spoke and who they spoke to, and let them talk about it, eventually they would get to a much more richly connected group. So you can shape networks by the fact that people have this norm that is internalized to them, that everyone should participate and everybody should talk to everybody. Right? That's the background belief that these people have, and what they would discuss is, oh, they should be more like that. And what our results on many different organizations show is this background belief that people have is actually a very good background belief. It indeed leads to higher performance. But you don't always have to do this. This is a funny one. So we went into a call center, and we looked at the patterns of communication. And in call centers, they manage the employees to make sure that they don't talk to each other, because that's seen as wasting time. And one of the things they do is they give them breaks that are staggered, so nobody gets to talk to anybody else. And what I suggested was, no, give everybody in a group a break at the same time, right? That way you could have more interaction. So I got a little out of order here. When we studied it before, just when we came in first, we looked at them for 6 weeks, we found this little graph. So along the bottom is average call handling time. This is expensive. This is cheap, right? This is almost directly money for a call center, how long you spend with each customer. And the vertical is this engagement measure, which is cohesion is another word for it. Network constraint is another measure. And what you find is, again, about 40% of the variance in call handling time, independent of tenure, gender, age, etc., is how much the employees talk to each other. And remember that they manage the call center to minimize that. So what I suggested is they change the break structure, which they did. They gave everybody a break at the same time. The cohesion went through the roof, and productivity also went up almost 25%. And they saved $15 million a year. It has nothing to do with the content. It's just the pattern of communication. So let's go from inside companies to out in the world. So for several years, we've been building systems that run on mobile phones to measure these networks. A smartphone today can give you several types of networks: a proximity, who you spend time with, who you call, can look at your Facebook, can look, do you go to the same places? These are all types of social networks. And we have a system we built called FUNF. Stands for Friends and Family, or Fun Framework. It has a couple different things. But it's open source and available for free. At this point, almost 1,000 groups of sociologists, psychologists, and stuff have downloaded this, because you can build your own sensing network in under 5 minutes without any problem. So you wanted to deploy and sense a network in your group, it will take you minutes, literally, to do it. So go and visit it. We won an award from South by Southwest. Yay, isn't that nice? And you can do things with this that are surprising. So for instance, in an experiment where we looked at a dorm that had around 85 people for a year, we looked at all of their interactions, their telephone calls, their SMS, who they spent time with, who went to the same places. We found that ego network properties for those various networks, not one network, many networks, those ego net properties could accurately diagnose health problems. Problems like onset of the flu, onset of gastrointestinal problems, non-clinical depression. And you could also do things like you could estimate personality with some accuracy and so forth. And Matt Amnall, who's the student who was in charge of this project, has gone off and formed a company, Ginger.io, which is now doing that on a large scale commercially. What I'm interested in here, though, is not just how ego networks change, but can we look at how networks in general between people change out in the wild. And so this is the sort of stuff we want to do. It's not obvious that you can do that. If influence in networks was just simply a matter of argument and strategy, it would be difficult to measure any sort of network influence as a function of the things we can get off of a phone. But the results we had with the sociometers would argue that you should be able to do some of this. So we took this dorm, which was a very sort of cohesive co-op-like dorm, where we knew we could get almost all of the social ties. These people ate together, slept together, argued together, played together, and every once in a while they would go to classes, right? But we had most of the social networks that were relevant there. Again, proximity, call, etc. And what we found for many of the different properties that you'd be interested in, change in body mass index, change in eating behavior, politics, is that you could most accurately predict those things by looking at their exposure to other people. So if you looked at what the people you spent time with were doing, were they all gaining weight? Were they all becoming Republican, whatever? That was the best predictor of people. Now this is against the sort of thing that people say typically as the results of Christakis and Fowler, but you need to remember in that result, in the Framingham study, they used a snowball method of recruiting people. So the people there were already friends in some sense. And they didn't have a good picture of exposure to the people in the community. So when we look at this, we find no statistical significance between what your friends do and what you do. In a much larger study, you might find the statistical significance that they found. But we found the much more powerful effect was through exposure. So when you're in Rome, you tend to do what the Romans do. If it means taking that third slice of pizza, you take the third slice of pizza. See, I'm running short on time here. I'll just mention a few things that we could do. There's papers about these. So for instance, you could actually look at co-location and the mixing of co-location over time and use that to predict voting behavior during the Obama-McCain elections. I don't have time to explain it, I'm sorry. Also, there's a correlation between smartphone apps and which things people download on their phone, and co-location. The people who spent more time together seemed to download more. And Wei Pan extended this and did a very careful job of this. So he's here too. There he is. And he looked at the combination of all these networks to be able to predict people's behavior at downloading apps. So if you combine the exposure across these different networks, and principally the proximity call networks, what you can do is you can predict what apps people will download as a function of the people they're exposed to, and get an accuracy that's around 45%, which doesn't sound so good, but you need to remember there's a lot of different apps, right? So there's something that is sort of a canonically cognitive decision, but yet you can do a very good job of predicting it by looking just simply at this exposure variable. And it's time. It's a number of times. It's not unique individuals. It's not arguments. It's not many other things. So the final thing I wanted to mention is using these types of things to shape networks. And so a classic problem is, if I want to change people's behavior, and I believe that exposure is one of the main variables, what would I do? Well, the sort of logical thing to do that Iyad and myself and Ankur Mani did is say, well, maybe what we can do is incentivize people to change their exposure around certain topics. So instead of having an externality, like, for instance, too much energy consumption or not enough physical activity among a group and it's sort of spread and it's nobody's fault, what we wanted to do is localize it to your immediate and strongest social networks. So if we could get your local social network to expose you to the idea of being more active or saving energy more often, then we felt that we could probably obtain better changes in your behavior. And the mathematics of that are basically the same sorts of mathematics for externality costs and peer pressure that Matthew Jackson, Stanford has introduced. But now what we've done is added a final term, which is an incentive to apply peer pressure to people to change their behavior. Okay? And what we found is when we ran this on a group of young families for a period of 3 months, and we compared incentives to have people become more active, and activity was measured on their smartphone and fed back to them. We had one condition where it was measured on the phone, it was fed back, and we gave them a $1 reward for becoming more active. We had another condition where they got that same reward, but they got to see what their nearest buddies would be doing also. And then the third condition is where instead of giving them a reward, we gave their buddies rewards for their behavior. So the way to think about that is that, you know, when you show up someplace, the people you spend most time with have an interest in talking to you about your activity level. And you have an interest in talking to them about their activity level, because the whole community is involved in it. And what we found in this experiment is that the straightforward ways of giving incentives worked not terribly well. That's 0.012. So that's the amount of activity per dollar, activity change per dollar. The social media, which is a reward plus letting you see what other people are doing, worked better. That's the 0.0253 number. But this business of giving rewards to your buddies was roughly four times as effective as the standard reward mechanism. That's the 0.4. So the idea that behavior is, to a very large degree, determined by exposure, not completely. Obviously, it's a stochastic process with these sorts of measurements. And then you can leverage it by changing exposure, is what I'm telling you here. So I wanted to end on two things. One is, we have data that nobody else in the world has, and we've put a lot of money and effort into doing that. So the Friends and Family study has location, calls, SMS, Facebook activity, credit cards, apps, psychological variables such as personality, you name it, we collected it, okay, for a period of a year for this living community of young families. And we'd love to collaborate with you if you have an idea on what to do with this sort of data. The social evolution experiment was a year of data with similar sorts of variables. This is a very cohesive co-op sort of living situation where you have as close as you can get to all of the social ties. And then you're probably familiar with earlier reality mining data, so that's available too. And then things like, for instance, the Chicago data where we looked at people for a month in their working conditions and looked at behavior and communication patterns as a function of productivity. That's also something that we have. And then the final thing is, you can talk to me about it, but you can also talk to all of my collaborators. We have Wen Dong is going to be talking about what I think is the first individual level model of flu propagation. And the reason he's been able to do that is because of this very detailed, millisecond by millisecond data that we have about whole communities for long periods of time. Wei Pan is going to talk about a new generative model of city scaling, which I find really, really interesting, and I suspect you will too. Yaniv Alshuler is going to talk about improving the wisdom of crowd in a 2 million person social network, work that's really quite interesting, and Wei Pan has a poster about that also. And then a couple other ones here, and I'm out of time, so thank you.